Weather is one of the most common factors that impedes aircraft operations. Low visibility, precipitation, and fog are just a few obstacles to safe aircraft operation. The Instrument Landing System, or ILS, is one tool available to pilots to safely land in instrument meteorological conditions and is used as the primary instrument approach at thousands of airports worldwide. My name is Kyle Warner. I'm an air traffic control student here at the University of North Dakota. We will explain what an ILS is, how it works, what goes on in the cockpit during an approach, and how controllers are required to issue the approaches. Today on ATCast.
Thank you. JetBlue 1264 Boston, ground taxi ramp via November and Alpha. Boston Tower, Gulfstream 717, I'm for props with you on the ILS 4 right approach. Yes, there's 741 is checking out. 741 Boston Tower, thanks for your phone. 737, just inside Mount, runway 4 right, clear to land, taxiway 1015. 417, thanks for the service, terminates, clock VFR, first exchange, service, way back. 117, okay, good night now.
Let's begin by defining what an ILS is. ILS stands for Instrument Landing System. It consists of 4 elements: localizer, glide slope, marker beacons, and approach lights. It's called a precision approach because both vertical and lateral guidance are provided to the aircraft. The localizer is a radio signal that provides lateral guidance to an aircraft on approach. It originates from an antenna that is usually located about 1,000 feet beyond the departure end of the runway. It actually sends 2 overlapping frequencies, or lobes, and the point where those lobes overlap denotes the extended center line of the runway. These signals are generally guaranteed to be accurate to a distance of 18 miles from the runway threshold. Aboard an aircraft, the ILS equipment detects the point where the lobes overlap and causes the localizer needle in the cockpit to move in relation to the position of the aircraft. When an aircraft is straight and level and tracking the localizer, it is said to be established on the localizer. The localizer antenna also sends its signal in the opposite direction on what is called the localizer back course. We'll talk about the localizer back course a little later. The glide slope provides vertical guidance to the approaching aircraft. Like the localizer, it sends 2 overlapping radio signals. The point where the signals overlap indicates the appropriate approach angle to the runway. Most glide slopes provide a 3-degree descent angle, although this can vary slightly from one airport to another. In some instances, the glide slope signals may overlap in more than one place, producing a false glide slope. The false glide slope will typically be formed at about 12.5 degrees from the horizontal, though there may be more than one false glide slope present. There will never be a false glide slope below the correct slope of 3 degrees, so for this reason, aircraft should be assigned altitudes during the approach clearance that will allow them to intercept the glide slope from below. Pilots should never have to chase the glide slope from above, as this can require steep descent that may be uncomfortable for the passengers. Glide slope antennas are designed to guide the aircraft to the touchdown zone of the runway, as opposed to the runway threshold, and are typically positioned right next to the runway's touchdown zone. This allows for adequate wheel clearance over terrain or other obstacles for large aircraft. Marker beacons comprise the 3rd element of the ILS system. They exist to provide position updates to pilots conducting the approach and assist the pilots in judging their distance from the runway. If the aircraft is conducting a localizer-only approach, marker beacons allow the pilot to determine whether he or she is descending at the correct rate. There is always an outer marker located 4 to 7 miles from the runway threshold. Some systems also have a middle marker about 3,500 feet from the runway threshold, and an inner marker between the middle marker and the runway threshold. The final component of the ILS is the approach lights, which aid the pilot on the approach once the aircraft has descended below clouds and in reduced visibility conditions. Approach lighting includes elements like extended centerline lighting, runway end identifier lights, and visual slope indicators. Here to explain exactly what happens in the cockpit as an aircraft flies an ILS approach is Mark Duesenberry, a flight instructor here at UND. Mark?
Thanks, Kyle. Today we're at UND Aerospace's Level 6 CRJ-200 simulator. I'm with my colleagues Matt Upsall and Mark Hastings. Today we're going to demonstrate pilot workload during an ILS approach. During an ILS, the pilot flying and the pilot not flying have various duties to accomplish. First, we're going to look at an ILS approach to runway 4 left at John F. Kennedy International Airport in New York. Then we're going to look at what happens if ATC issues late turns during vectors to the ILS approach. Also, in the event of a missed approach procedure, we're going to look at the high pilot workload they will experience. Currently, the aircraft is positioned on the base leg for the ILS runway 4 left into New York's JFK Kennedy International Airport. Currently, the aircraft is in IMC conditions.
Heading 075, 1500 to establish, cleared ILS, runway 4 left, Superjet 2245.
Approach mode. And bug 160.
After receiving the approach clearance, the pilot flying turns to the intercept heading. The pilot not flying begins to configure the aircraft for landing.
Flaps 20.
Configuration changes range from changing the heading bug, setting approach mode, changing flap configurations, and finally, prior to landing, putting the gear down.
Bug runway heading.
045. Superjet 2245 over to tower. 2245, 7 mile final, runway 4 left. Clear land 4 left.
Approximately 4 to 7 miles from the runway, approach control will transfer the aircraft to tower control. Currently, the aircraft is located 6 miles from the runway threshold at 1,500 feet.
Gear down, flaps 30 before landing, check to line.
Flaps 30.
The glide slope is now active. The pilot not flying selects the gear down and the flaps to the 30-degree position.
Gear
Flaps
down,
45, bug gear F.
Flaps 45 degrees, speed 144.
At glide slope intercept, the pilot flying calls for the final flap setting and slows to approach speed. Descent from 1,500 feet to minimums begins at this point. At all times throughout the approach procedure, the pilot not flying monitors the flight parameters.
Altimeters and instruments cross-checked.
The aircraft is approximately 700 feet above the ground and 2.5 miles from the runway.
No flags, gear check down, clear to land.
500.
200 in nose.
After reaching visual conditions, the pilot not flying calls runway in sight, and the pilot flying transitions to visual conditions.
Runway in sight, 12 o'clock.
Landing.
Minimums.
Minimums.
The minimums are the lowest point at which the aircraft can fly without visual reference to the surface.
$50, $40, $30, $20, $10.
Spoiler screen.
If the aircraft begins to pass through the final approach course and an ATC clearance has not been issued, the pilot not flying will question ATC.
Approach to Superjet 2245, get a turn. Roger, left heading 015, Superjet 2245. No flags, gear check down, clear to land.
500.
At this time, the pilot not flying begins to search for clues for the runway environment.
minimums.
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 No contact, go around.
Max thrust, flaps 8, spoilers in.
Flaps 8, spoilers in. Positive rate.
Gear up, speed mode. Heading mode.
If visual contact is not maintained, the pilots will execute a missed approach procedure.
Pilot gauge.
It's like nav.
Nav mode. Flaps up, climb, thrust, climb, check.
The missed approach procedure is one of the highest workloads the pilots can experience. Initially, the task is dominated by aircraft configuration changes and navigating to the missed approach fix. Upon reaching the missed approach fix, calculating fuel and determining an alternate plan of action are various pilot duties at this time. That's it from the simulator. Kyle, back to you.
Thanks, Mark. Now let's take a look at Academy Airport, which is the basis for air traffic control training here at UND. Academy has two ILS approaches, to runway 28 right and runway 28 left. There are also localizer back course approaches to runway 10 left and runway 10 right. A back course approach is basically a localizer only approach. It is non-precision because no vertical guidance is provided to the aircraft. The other major difference for pilots is that the signal is reversed. In other words, if the localizer needle moves to the left, the aircraft must turn right to stay on the runway center line. The localizer signal is only about 5 degrees wide, and because of this, pilots should never be instructed to intercept the localizer or localizer back course at an angle greater than 30 degrees. At Academy Airport, aircraft are usually vectored to the ILS approach for runway 28 right. In advanced classes, runway 28 left will also be in use. Since the runway headings are 280, a typical traffic pattern will be a downwind leg of heading 100 or 280, depending on the runways in use. From the north, the base turn will be heading 190 or heading 010 from the south. A 30-degree intercept heading for runway 28 right or 28 left from the north is 250, and from the south, 310. For runway 10 left or 10 right, the 30-degree intercept heading is 130 from the north or 070 from the south. Note that 30 degrees is the maximum intercept angle you may use. Any heading less than 30 degrees can also be used if appropriate. When vectoring aircraft to the final approach course with up to a 30-degree intercept angle, they must be established on the localizer or localizer back course at least 2 miles outside the final approach gate. This gate is located 1 mile outside the final approach fix, Woody in the case of runway 28 right or Boldy for runway 10 left. For runway 28 left, the final approach fix is Onetta, and Ritchie is the fix for runway 10 right. To summarize, aircraft must be straight and level by 8 miles from the runway threshold. Aircraft intercepting the localizer or localizer back course less than 2 miles from the final approach gate must be given no more than a 20-degree intercept angle. Pay attention to the type of aircraft if you are trying to sequence it on a shorter approach, since larger aircraft make wider turns and cannot slow down as quickly as smaller ones. Aircraft should be assigned an appropriate altitude for the approach that will allow them to intercept the glide slope from below. An example of an appropriate altitude for runway 28 right would be 3000 MSL. Now we will look at the phraseology for ILS and localizer back course approach clearances. The format of the clearance is easy to remember by using the 4-letter acronym PTAC. PTAC stands for Position, Turn, Altitude, Clearance. Each of these elements in this order must be included in the clearance. Position is the distance of the aircraft from the outer marker. The turn is the heading you are issuing to the aircraft to intercept the localizer. The altitude is the altitude you are instructing the aircraft to maintain until it is established on the localizer. Finally, the clearance authorizes the pilot to conduct the approach as published on the approach plate. This clearance also authorizes the pilot to conduct the published missed approach procedure in the event that the pilot cannot complete the approach. American 424 Heavy has been turned on base for runway 28 right, and the controller is about to issue the approach clearance. Listen for the 4 elements as the controller issues them.
American 424 Heavy, 10 miles from Woody, turn right heading 250. Maintain 3000 until established on the localizer. Cleared ILS runway 28 right approach.
250, 3000 until established on the localizer. Cleared ILS runway 28 right approach. American 424 Heavy.
For runway 28 left, the clearance is almost identical, Simply substitute the name of the runway 28 left outer marker.
Northwest 323, 9 miles from Onetta. Turn left heading 310, maintain 3000 until established on the localizer. Cleared ILS, runway 28 left approach.
Heading 310, 3000 until established, cleared the approach. Northwest 323.
The back course clearance is quite a mouthful, but the PTAC elements are still there.
US Air 880 Heavy, 11 miles from Boulder, turn left heading 130, maintain 3000 until established on the localizer back course, cleared localizer back course, runway 10 left approach.
Turning left heading 130, maintaining 3000 until established on the localizer back course, cleared localizer back course, runway 10 left approach, US Air 880 Heavy.
Now for a quick review. ILS stands for Instrument Landing System. It consists of 4 elements: a localizer, glide slope, marker beacons, and approach lighting. The localizer provides lateral guidance to the runway, and the glide slope provides vertical guidance. These 2 elements make the ILS a precision approach. The localizer also sends its signal back along the opposite runway's heading. This is called the localizer back course. It only provides lateral guidance and is not a precision approach. Pilots have their hands full during approaches and should not be given any unnecessary instructions. Because the localizer signal is only 5 degrees wide, aircraft must not be instructed to intercept the localizer on headings greater than 30 degrees from the runway heading if being vectored to intercept 2 miles or more from the final approach gate. If intercepting the localizer at less than 2 miles from the final approach gate, aircraft must be given intercept headings that are no more than 20 degrees from the runway heading. Due to the possibility of false glide slope signals, aircraft should be assigned altitudes during the approach clearance that will allow them to intercept the glide slope from below. The ILS and localizer back course phraseology consists of 4 elements called PTAC. PTAC stands for position, turn, altitude, and clearance. On behalf of UND Air Traffic Control, the Student Air Traffic Controller Association, and the Aerospace Network, I'd like to thank you for tuning in. My name is Kyle Warner, frequency change approved. For more information on UND Air Traffic Control and to see other videos in this series, visit www.aero.und.edu or search for ATCast on iTunes University.